Hello my dear students, in this lecture we are going to see del operator. Now my dear students, here to understand this del operator, basically we have to understand some properties of the vector. So first of all we will understand some basic properties of vector, and then we will go for the understanding of del operator, because this del operator is very much important for the complete thoroughly understanding of this electrodynamics topic, right? Generally they will not ask question on simply del operator, but this del operator is represented by del. This is a sign for the del operator. It is represented as or pronounced as del, but this del operator is very much important for further our understanding as well as for solving the questions which they will ask in your university on coming topics, right? Now let us understand here. Let us say if I consider three dimensional in one object. Let us say if I consider axis as, let us say this is a vertical axis is called y-axis, then horizontal axis is called x-axis here, and perpendicular to this, see this is on your page, and perpendicular to your page, see x-axis is horizontal line on your page, y-axis is vertical line on your page, and perpendicular to your page there is a z-axis, means towards you. This will be the z-axis, right? Now angle between all the axes is 90 degree. Here angle between xy is 90 degree, then yz is 90 degree, and xz is also 90 degree, means these are mutually perpendicular to each other. Now my dear students, the unit vector along x-axis is called I cap. I cap is unit vector along x-axis. Similarly, j cap is unit vector along y-axis, and k cap is unit vector along z-axis. Now all these things you have already learned in your 11th standard physics as well as 11th standard mathematics, right? I cap, j cap, and k cap are the unit vectors along x, y, and z direction, right? So here I will write I cap, j cap, and k cap are unit vectors along x, y, and z direction, right? Now my dear students, let us say due to some reason you have displaced along x-axis by amount ax. At the same time your displacement along the y-axis is by ay, and at the same time your displacement along z-axis is az, right? Ax, ay, az are the actual displacement along x, y, and z axis. Therefore the vector here, displacement vector, let us say the displacement vector, if I represent with a is my displacement vector, right? But here displacement along ax is, along x-axis is ax, and unit vector is I cap. Therefore it is written as ax I cap plus ay j cap plus az k cap. These are the displacements along ax is component of displacement along x-axis, ay is component of displacement along y-axis, and az is component of displacement along z-axis, right? Therefore here vector a is a vector. It is a vector quantity, vector a, right? And ax, ay, and az are components of vector, a, right? Simultaneously, let us say you have another vector. Let us say you have another vector, vector b, which is written as, this is again displacement vector. Now this displacement vector is written as bx I cap plus by j cap plus bz k cap. See, here I am revising the things that you have already learned in your 11th and 12th standard, right? Now, or you might have seen these things in your physics 1 as well as in mathematics, right? Now my dear students, if I take dot product of a and b, now I am introducing here dot product, right? Now a as well as b is a vector, b is a vector, and here arrow represents vector. Now bx, by, bz are the components of vector b. Bx along x-axis, by is component of b along y-axis, bz is component of vector b along z-axis. Likewise you can understand. Now let us understand the dot product, because this is very much important for the understanding of del operator. Now this product also you have studied in physics 1, right? Now this is a dot product of vector a and b. It is nothing but vector a dot vector b. And my dear students, let us say this dot product is always a scalar quantity. Now dot product of any two vectors is always scalar quantity. because here there is a direct multiplication, component multiplication. Therefore, it will become ax bx plus ay by plus az bz. Means here direct component multiplication we have to do and addition between them. This is how we are calculating dot product. And my dear students, dot product of any two vector is always scalar. Means dot product of two vector here a dot b is scalar, is scalar. Means this product, this quantity which is nothing but, let us say, yes, therefore this yes will be the scalar. So always remember, the dot product of any two vector is always scalar. This you must remember. Now let us understand cross product. Now if I take cross product of two vector, how to represent, right? You might have studied this also, the cross product of vector a and vector b. If I write vector a cross vector b, if I write vector a cross vector b, then it is generally represented in the form of matrix. Now this also we are going to see in this topic. Don't worry, this dot product, cross product, again we have to see in detail, right? Now this cross product is written as, see, it is represented in the form of determinant. This is called determinant symbol in mathematics, right? Now ijk are the unit vectors along x y z. Therefore these unit vectors I have to write here, ijk. Means in first row there will be a ijk unit vectors along x y z. Then as a is written first, therefore components of a we have to write here, that is second row ax ay az. And in third row we have to write the components of b, that is bx by bz. This is called cross product. This is a cross product, and we have to find determinant of this matrix, right? Now how to find determinant? Now here again I am telling you how to find determinant, but completely this determinant finding, this dot product finding, this cross product finding is a purpose to understand in physics 1 only. Here only for your simplification or for proper understanding I am revising the things, because later we have to solve the numericals also, right? But here many teachers will start with the these things, they will assume you already know and they will start further, right? Now how to find this determinant? See, I have to take this I cap. Firstly I have to, if I write here I cap, let me take another color, right? If I take blue color here, see, I cap into determinant of, see, here I have to delete first row and first column. If I delete first column and first row, then other elements I have to consider here, determinant of these components, right? Therefore determinant of ay az, then by bz, then in between there is a minus sign, minus j cap. For second there is a minus j cap. Then I have to delete the here second column and first row. Then other components I have to write, determinant of, then other components will be ax az bx bz. Therefore here ax az, just a minute, ax az, then bx bz plus k cap. Then alternative there is plus minus, so on we have to write I for I, plus for j, minus for k, plus. Now here k lies in, see, k lies in third column and first row. Then we have to delete first row and third column, and then we have to write other elements, right? Therefore determinant of plus k cap, determinant of ax ay bx by, likewise we have to write. And I hope that you are known or familiar with finding the determinant, right? So see, in curl of vectors, again we have one topic, that is curl. In this topic we are going to learn this, that's why here only I am telling you now how to find. Therefore it is equal to, again this is equal to I cap. See how to find determinant, this cross multiplication ay bz, ay bz, in between minus this cross multiplication by az, minus by az, then in between minus j cap. Then determinant of this 2 by 2 matrix is this cross multiplication ax bz minus this cross multiplication bx az. Therefore it will be written as ax bz minus bx az plus k cap, again this ax by cross multiplication minus ax ay cross multiplication. Therefore it will be, sorry, it is a bx, I think it is a See, for k cap, there will be a bx, by. See, here there is a bx. There will be a bx here, right? So this will become ax by minus bx ay. Likewise, we have to find the cross product, right? And this cross product, that is vector a. See, in cross product again there is a I j k component. In cross product again there is a I j k component. Means cross product is also vector quantity. Therefore, vector a cross vector b is nothing but again other vector. Let us say vector. Yes, this is vector. Cross product of two vector is always vector, and dot product of two vector is always scalar. Right, this is very important. Cross product of two vector is vector, dot product of two vector is scalar. Now with this basic understanding, let us move forward for the understanding of del. Now my dear students, again you might have learned about the speed. What is speed? Speed is nothing but distance divided by time. Speed is distance divided by time. Now let us understand this concept. Therefore from this can I say the distance, let us say distance is x is equal to speed. Let us say speed is nothing but here, if I write speed as v into time is t, therefore distance is equal to speed into time, right? Now let us understand here, therefore can I say this x is a function of time, distance is a function of time. Let us say at time t1, at time t1 I am at position x1. Now I have started from this position and I am moving towards positive x-axis, and after some time t2, I will be at position x2. Now here I am moving with some speed v. I am moving with some speed v. Right. Now what is the distance or traveled or displacement? What is the distance traveled? That is x2 minus x1, which is written as del x, change in x. X2 minus x1 is written as change in x, that is distance traveled. Right. Again, what is the time required? What is the time taken? Can I say the time taken will equal to t2 minus t1, which is written as del t, which is written as change in time, right? And I am moving with velocity v, right? Now my dear students, see here, this time change I can write dt also, dt del t, or I can write dt also for very small change, right? Now my dear students, see, as x is a function of time, so in mathematics what we are doing, this change in x is nothing but here velocity, that is speed into time. Therefore it will become, this speed is nothing but, see, this speed becomes, let us say this speed becomes change in x with respect to change in time, change in x with respect to change in time. This is called rate of change of x, rate of change of x, change of x with respect to time t. It is called rate of change of x with respect to time t, which is nothing but speed. Therefore, this del x, change in distance, will be written as rate of change of time dx, rate of change of x with respect to time dt, into del t. This we have written as small dt, you can write, or we can write del t. T2 minus t1 written, therefore it is, we have to write del t into del t. This is how we can write. Therefore, this is change in x, change in x. This is change in time. Del t is change in time, and this is a rate of change of, this is a rate of change of x, change of x with respect to time, right? So my dear students, so understand how I have written here. Therefore if x is a function of time for all the variables, we are doing like this only, then change in x will be equal to rate of change of x with respect to variable into change in variable, into change in variable. This is how we can write, because variable is time here. As time changes, x changes. Therefore, change in x can be written as rate of change of x with respect to variable into change in variable. This is very important. This is a mathematics, my dear students. This is a mathematics. So here, as we have seen, see, x is a function of only time. Then we can write change in x is equal to rate of change of x with respect to time into change in variable, that is change in time. But what happens if any one component is a function of other three components? Let us say temperature. If I talk about temperature, let us say temperature is a function of, if I talk x, y, z, temperature is a function of x, y, z. Let us understand the similar thing if temperature is a function of only x. If temperature is a function of only x, temperature I will represent with T. let us write this temperature as T, right? Therefore, this temperature, which is nothing but T, is a function of only X. Then how to find change in temperature? Then change in temperature del T. This is this del is different, and this del operator is different. See, del operator is reverse triangle. Del operator is reverse triangle, and this del is change in time or the change in temperature. This is change, and this is reverse operator, reverse triangle, and this is the inline triangle, right? This can be written as, see, change in temperature with respect to variable. Variable is X here, into change in variable, into change in variable. This is how we can write. If this temperature is a function of three coordinates, let us say this temperature now is a function of X, Y, Z. See, my dear students, I already know that these are very basic things. Already you have learned these things in previous physics 1 subject, but these things are very much important for the better understanding of del operator, and del operator is very much important for the further understanding of complete topic, right? So now, my dear students, here the meaning is the temperature is changing along X as well as Y along as well as Z. Here the meaning of this is temperature is a function of X as well as Y as well as Z, right? Therefore, my dear students, how to write this? Now, if X changes, then also temperature changes. If Y changes, then also temperature changes. If Z changes, then also temperature changes. If all together changes, then also temperature changes. Therefore, in such cases, see, this dt by dx is called complete derivative. In mathematics, it is called complete derivative, rate of change of temperature with respect to x. It is a complete derivative. But here, if there are more than two variables, then there is a concept of partial derivative. That means partial derivative will be dou t by dou x. Dou t by dou x. It is a partial derivative. Partial derivative means here in this derivative we are considering change of temperature with respect to x only. In this partial derivative we are considering change of x with respect to x only, right? Similarly we can write for y, similarly for z also, but actually in reality temperature is changing with x, y, z with all. Therefore, this total change in temperature can be written as partial change of temperature with respect to x into del x, right? Here similarly I am writing this is partial change of temperature with respect to x, but temperature is also changing with respect to y. Therefore, plus partial change of temperature with respect to y into del y, plus similarly temperature is changing with respect to z, partial change of temperature with respect to z into del z, into del z. Likewise we can write into del z. Likewise we can write. And my dear students, this is change in temperature, that is final temperature T2 minus initial temperature T1. This is called change in temperature. Let us consider one 3D element. Let us consider one 3D element. This is a y direction. Here horizontal is x direction, and here it is a z direction. Now, if I consider one 3D element, very small element of dimension dx, dy, dz. So here I will draw this very small element of dimension dx, dy, dz. Let us say this is the element, right, along all the three direction. Now, my dear students, let us say this distance is very small distance dx. This distance, vertical distance, is very small distance dy, very small distance dy, and here this distance is very small distance dz. This component, therefore, this component is of dimension dx, dy, dz. Right. Now, on this component, if I consider one point, let us say point P1 here. This is the first point. Now, this point will be having coordinates. Let us say this point 1 is nothing but P1, point 1, P1. Now, this point, let us say I am assuming the coordinates as x, y, z, along x, along y, as well as along z. These are the x, y, z components. Now let us consider one more point. See, I will consider one more point at this two location, point 2, right? And I have to find the coordinates of point 2. Therefore, let us say coordinates of point 2 will be equal to, see, what is the x coordinate? This x coordinate, this x plus dx. Therefore, x coordinate is x plus dx or del x. We can write del x also. Let us write them del x. Here if I write del x, del y and del z. Change in x, change in y, change in z. Na? Therefore, if I write here, see, del x, del y, change in y, change in x and change in z. Therefore, this will become x plus del x. This is the x coordinate. What is the y coordinate? This is y plus del y. Y plus del y, right? This is y plus del y. Therefore, y coordinate is y plus del y. Similarly, the z coordinate will be, see, z plus del z. It will be z plus del z, z plus del z. This will be z coordinate. Right. Now, my dear students, let us say if I draw one vector r1 from origin to 1. Let us say this is a vector r1. Right. Then what will be the vector r1? See, any vector a we have seen as axi plus ayj plus azk. Similarly, this vector r will be equal to what is x? What are the coordinates? X, y, z. Therefore, it will become xi plus yj plus zk. And similarly, if I write here vector r2, let us say the vector r2 like this, right? From 0 to 2, from 0 to 2 is vector r2. Therefore, this vector can be written as vector, this is r1, vector r2 will be written as the coordinates of r2 are, that is point to r. Therefore, I have to write x plus del x into I plus similarly y plus del y into j plus z plus del z into k, right? And my dear students, if I join 1 and 2, here let us join 1 and 2 and find vector between them. If I join 1 and 2, this will be the change in vector r. This will be change in vector r, right? Therefore, here if I find change in vector r, see, this is a simple mathematics that already you have learned in physics 1 and mathematics 1. Therefore, change in vector r will be equal to r2, vector r2 minus vector r1. So here you have both formulas. Now vector r2 minus vector r1, this x will get cancelled, y will get cancelled, and z will get cancelled. Then what we will get? It will be del x I cap plus del y j cap plus del z k cap. This will be the vector r, right? This will be the vector del r, right? Which is nothing but r2 minus r1. Now here, as we have calculated vector r, vector del r. Now let us understand, my dear students. Here I got two vectors. These two vectors I am representing here or writing here. See, here I will erase everything and I will write whatever the two vectors I got. See, first thing I got here, vector del r, which is equal to del x I cap plus del y j cap plus del z, here del y j cap, just a minute, it will become del y j cap plus del z k cap. This will be the vector del r, right? Change in vector r. It is not del operator. Del operator is reverse of triangle, and it is a just triangle. That's why it is a change, right? Now, my dear students, see, again we have seen temperature. For temperature, we have seen temperature is a function of, if it is a function of x, y, z. Just now we have seen. Then this change in temperature can be written as dou x by, here, sorry, dou t by dou x, change of, because temperature is changing with x, y, z. Therefore, partial change of x, partial change of temperature with respect to x plus partial change of temperature with respect to y plus partial change of temperature with respect to z. This can be written as dou t by dou x del x plus dou t by dou y del y plus dou t by dou z del z. This just now few minutes back we have seen this, right? Now see, my dear students, here vector r, this is del r is nothing but vector quantity. It is a vector quantity, and here temperature is a scalar quantity. Therefore, this is a change of temperature. Change of temperature will be scalar quantity. It is a scalar quantity because temperature is a scalar quantity, my dear students. And we have seen, see, if just now at the start of lecture we have seen, if vector a is given, that is axi plus ayj plus azk, this is a vector a. Similarly, vector b is given, that is bxi, it is bxi plus byj plus bzk. Let us say these are the two vectors, vector a and vector b, where ax, ay, az are the coefficient of vector a and bx, by, bz are the coefficient of vector b. Then what is the dot product? Vector a dot vector b is nothing but scalar. Is nothing but scalar, which is nothing but, see, this vector a dot vector b is nothing but scalar, which is nothing but the product of the coefficients, that is ax into bx, ax into bx plus ay into by plus az into bz. This is how we can write. At the start of lecture we have seen this. Now here properly understand. See, Del R is a vector quantity. Del T is a scalar quantity. This is a change in temperature, which is a scalar quantity. Here, by dot product of two vector quantities, we are getting scalar quantity. Means, and see, operators, see, and for operators, or we can say for here coefficients, it is a summation of multiplication of all the coefficients. Na? Therefore, can I say here, see, here with R, there is a del X, del Y, del Z, with del R. Right? These are the coefficients. Del X, del Y, del Z are the coefficients of del R vector. Similarly, here del T is a scalar quantity. Here del X is there is coefficient of del R. Del Y is also coefficient of del R. Del Z is also coefficient of del R. Now, by equating them, see, my dear students, by equating these two conditions, right? Here I have vector A, I have this scalar product, I have vector A, I have scalar product, then I can find vector B. Therefore, this del T, which is a scalar, it must be dot product of two vectors, and one vector is del R. So I have to find second vector, and second vector will be having coefficients dou t by dou x, dou t by dou y, dou t by dou z. See, for scalar quantity, it is a multiplication of and a summation of multiplication of coefficients, na. Therefore, here del x, del y, del z are the coefficients of del R. Therefore, this dou t by dou x, dou t by dou y, dou t by dou z must be the coefficient of another one vector, and this vector operator is called del operator. Let us understand how this is written. Therefore, my dear students, I will consider one del operator here. Del operator is reverse triangle. See, this change in temperature is different. This del operator is different. Therefore, this del t is a vector quantity. This del t is a vector quantity, which is nothing but, see, these coefficients I have to consider. See, it's dou t by dou x, dou t by dou y, dou t by dou z. I have to consider these coefficients. Therefore, it will become dou t by dou x I cap plus dou t by dou y j cap plus dou t by dou z k cap. Right. Similarly, if I take temperature common here, then can I write this del operator, which is vector quantity? Here, this is a vector quantity. This is a vector quantity. Del t is vector quantity, reverse triangle. Then it will be written as here I into C. If I consider here I into dou x of plus j dou y of plus k dou z of temperature T. Now from both side temperature term will get cancelled. From both side temperature will get cancelled. Now what this del operator will remain? Therefore this T gets cancelled. Therefore this del operator will become here I dou x plus j dou y plus k dou z. This is del operator, which is very important parameter. This del operator is very important parameter. Now, my dear students, this del operator is not a vector quantity. See, here I have shown the arrow, but it is not a vector quantity. It is just an operator. It is a vector operator. Here I will write this del operator. Let me erase something. See, just now we have seen del r, that is change in r vector, will be del x I cap plus del y j cap plus del z k cap. And similarly, we have seen the del operator, that is del t. This is a vector quantity. See, del operator I am using here. Del t will be equal to here I dou x plus j dou y plus k dou z. And my dear students, here also change in temperature. Del t is different. These both are vector quantities. These are the vector quantities. And change in temperature is a scalar quantity, which can be written as, here just now we have seen change in temperature with respect to x into del x plus change in temperature with respect to y into del y plus change in temperature with respect to z plus we can write change in temperature with respect to z into del z. Right, just now we have seen, and this temperature change is scalar quantity. Here triangle is used, here del operator is used. Now, my dear students, see, this scalar quantity is a dot product of these two vectors. Therefore, if I consider here dot product of two vectors, therefore, let us say del t, vector del t dot vector del change in r, I will get, see, what I have to write? I have to write the product of the coefficients, na. Therefore, here coefficients are, see, coefficients are del x, del y, del z. Then dou by dou x, dou by dou y, dou by dou z. Right. So this coefficient here, del t, here there is a t. Right. Here there is a t because here we have used temperature. Right. Therefore, it will become, see, the product dou t by dou x del x plus dou t by dou y del y plus dou t by dou z del z, right? And this is nothing but del t, means here del t, which is a del operator t dot change in r vector will be equal to change in temperature, which is a scalar, right? This del operator is a vector, this change in distance or displacement is a vector, and here change in temperature is a scalar, this is called a dot product. So my dear students, this del, which is nothing but del operator, is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z. Now this del operator is just a vector operator, it is just a vector operator, it is not vector, it is not vector, it is a vector operator. Means if this del operator is applied on the scalar quantity, because temperature is a scalar quantity na, see, if this del operator is applied on the scalar quantity, then we will get vector quantity. Therefore this is called just del operator, it is a vector operator and not a vector, not a vector, though the arrow is shown, but it is shown for the vector operator. Means if this vector operator is applied on the scalar quantity, then we will get vector quantity, because this vector operator is a I, j, k components. Therefore for this del, simply we can write the definition, this del is nothing but I dou by dou x. You have to remember this, very very important, it is a universal, in any subject you have to do the same. In coming 4 years many times you are going to use this. Therefore I dou by dou x, j dou by dou y plus k dou by dou z is a del operator. If this operator applied on scalar quantity, then we will get vector quantity, vector, right? Such as temperature is a scalar, but del t, del operator I have applied, it is a vector, right? And this del operator has many applications. Now here this del operator we have applied on the scalar function. Therefore whenever this del operator is applied on the scalar function, then it is called gradient of scalar function, then it is called gradient of scalar function. And whenever this del operator is applied on the vector, other vector, this del operator is applied on the other vector, how to operate? With dot product, del dot vector a. See, here a is a vector and del is a del operator, it is a vector operator. Whenever this del operator is applied on any other vector with dot product, right, what I am saying, with dot product, then it is called divergence of vector a, then it is called divergence of vector a, if this del operator is applied with cross product on vector a, whenever this del operator is applied on vector a, this is a vector, but here it was scalar, then we got, if del operator applied on scalar, we got gradient of scalar function. When del operator is applied on vector quantity with dot product, it is a divergence of vector a. If this del operator is applied on vector quantity with cross product, then we will get curl of a vector a, you will get curl of vector a. Thank you dear students. In next lecture we will start other parameters, that is gradient, divergence and curl of vector.